Our next competitor is Kumarini Senavaratne, who is a second-year PhD student in the Fluid Sciences group in the School of Mechanical and Chemical Engineering. Her supervisors are Winthrop Professor Eric May and Winthrop Professor Michael Johns. Kumarini's PhD title is Investigating Multi-Phase Behaviour in Liquefied Natural Gas Production Facilities, and her 3-minute thesis title for you today is Liquefied Natural Gas, a Problem of States. Please welcome Kumarini.
What is it that comes out of our gas stoves at home? The answer is natural gas. It is a mixture of hydrocarbons, but mainly made of methane. Natural gas is emerging as a very popular energy source due to its reduced greenhouse gas emissions in comparison to other fossil fuels. In fact, natural gas produces just half the amount of carbon dioxide and 1/10 the amount of air pollutants in comparison to coal. In Western Australia, majority of the natural gas produced is exported. It cannot be transported in its gas form and requires conversion to a liquid known as liquefied natural gas, or LNG. LNG is transported. LNG is a safer method of transportation, as well as it reduces the volume requirements by 600 times. This volume reduction is equivalent to going from a beach ball down to a ping pong ball. In 2013, Australia exported 24 million tonnes of LNG, which generated a revenue of $16.4 billion. This wouldn't be possible without liquefaction. The liquefying process occurs inside a heat exchanger, which is cooled using a refrigerant very similar to your freezer at home. Due to the very cold temperatures inside, any presence of heavier or larger hydrocarbons forms solids. These solids cause a huge amount of issues for the LNG industry. It starts by coating the surface of a heat exchanger, and after build-up leads to complete blockages of the system. These blockages cannot be resolved without shutting down the whole process and cleaning out the equipment. The LNG industry ends up losing money due to having delays in production as well as shipments to customers. Why is this a problem? If we want LNG to compete against other fossil fuels, we need constant supply. Nothing is known about the structure or the growth mechanisms of these solids. My research involves studying these aspects using magnetic resonance imaging, or MRI. MRI, as most of you know, is used for medical work, for visualizing soft tissues. Some of you may have even had an MRI or known someone who has. My research into the structure and formation of these solids will lead to better ability to predict and prevent their formation, thereby guaranteeing a better production quality, as well as reducing costs for the company, allowing LNG industry to compete against the other higher polluting fossil fuels. Thank you.